In this class, we are going to talk about how to find the derivative of a function. Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f of x equals to 4x squared minus 9x minus 12. Okay, how do we deal with this question? Well, to solve this question, don't forget in our previous class, there are various methods of finding the derivative of a function, and one of the methods is polynomial rule. According to polynomial rule, if you have f of x equals to ax raised to the power of n, where a is the coefficient of x and n is the exponent, the derivative of f of x will be equals to, you're going to take the product of the power to which the variable x is raised to. You're going to multiply it by the coefficient. Are you getting it? And this power is going to reduce by 1. Do you understand? So for this, I'm going to have n multiplied by ax raised to the power of n minus 1. Do you understand? We've talked about this in our previous class. So if you missed the previous class, you can always check the playlist on this channel. Do you understand? Okay, now, with respect to what we have here, this method, this rule is called polynomial rule. You understand? Okay, so let's use this rule to solve this question. The derivative of f of x will be equals to, okay, now you're going to differentiate this term individually. You understand? You're going to differentiate each term. You're going to differentiate it individually. So, and don't forget, in differential calculus, if you take the derivative of a constant, you're going to have 0. Do you understand? Okay, so let us start with the first term here. We're going to have 4 multiplied by 2x raised to the power of 2 minus 1. Don't forget, because I told you the power is going to multiply the coefficient of x, and this power is going to reduce by 1. Are you getting it? So if you compare 4x squared and ax raised to the power of n, you will discover that the value of a is 4. Are you getting it? And n is the power to which x is raised to. Do you get it? So I'm going to have 4 times 2x raised to the power of 2 minus 1. Okay, now let us differentiate negative 9x. For this, I'm going to have minus 9. Okay, differentiate x. I'm going to have times 1x raised to the power of 1 minus 1. Do you understand? Because x here is raised to the power of 1. Are you getting it? Even though the 1 is invisible, the power to which x is raised to is 1 here. So 1 multiplied by 9, that is what I have here. And the power will reduce by 1. You're going to subtract 1 from the power, okay? Now, negative 12 is a constant. So, and I told you if you differentiate a constant, you're going to have 0. So yeah, let us simplify. For this, I'm going to have 4 multiplied by 2. I'm going to have 8. Now, x raised to the power of 2 minus 1. 2 minus 1 is 1. So, x raised to the power of 1 will give me 1. Are you getting it? So, minus 9 multiplied by 1. That is what? Negative 9. X raised to the power of 1 minus 1, right? So, I'm going to have minus 9x raised to the power of 1 minus 1. 1 minus 1 is what? 0. So, I'm going to have this. So, the derivative of f of x will be equals to 8x minus, now, don't forget, according to the law of indices, x raised to the power of 0 will give us 1. Minus 9 times 1 will give me what? Minus 9. So the answer to the derivative of this function is 8x minus 9. Do you understand? Okay, let's look at one more question. This rule that we employ here is called polynomial rule. Okay, polynomial rule. Polynomial rule. You see, in differential calculus, the structure of the question will tell you the rule to use. Are you getting what I'm trying to say? Okay, so let's try this question. Let's say we have y equals to x raised to the power of 9 minus 2x raised to the power of 8 plus 5x raised to the power of 7 minus 2. Okay, you are given this function. You are asked to find the derivative of it. Okay, to differentiate this function, derivative of y equals to, now don't forget, according to this rule, the power is going to multiply the coefficient, right? And the power is going to reduce by 1. That is, you're going to subtract 1 from the power. So for this, I'm going to have 9 times x raised to the power of 9 minus 1. Okay, now I'm going to have minus 2 times, now this 8 will multiply the coefficient of x here, minus 2 times 8 x raised to the power of 8 minus 1. Are you getting it? Plus, okay, 5 multiplied by 7 x raised to the power of 7 minus 1. Then, if you differentiate negative 2, you're going to have 0 because the derivative of a constant will give you 0. So, there is no need to write that, okay? Now, let us simplify. derivative of y is equals to 9x raised to the power of 8 minus 16x raised to the power of 7 plus, okay, 5 times 7 is what? 35, plus 35 x raised to the power of 6, okay? So that is the solution to that question. The derivative of this function is this. Okay, let's look at one more example. Let's say you are asked to differentiate f of x is equals to 2x raised to the power of 7 minus 2x raised to the power of 4 plus 5x raised to the power of 3 minus 9. Okay, how do you take the derivative of this function? You're going to employ this rule. This rule is very important, okay? It is called polynomial rule. Use the product of the power and the coefficient, then the power reduced by 1. Do you understand? So for this, I'm going to have f of x, derivative of f of x is equals to 2 times 7 x raised to the power of 6 minus 2 times 4 x raised to the power of 3 plus 5 times 3 x raised to the power of 2. And if you differentiate a constant, you're going to have 0. Do you understand? So for this, I'm going to have the derivative of x, the derivative of f of x will be equals to 2 times 7 is what? 14. So I'm going to have 14x raised to the power of 6 minus negative 2 times 4. That is what? Negative 8. Negative x. Okay, negative 8x raised to the power of 3 plus 5 times 3 is 15. 15x squared. Okay, so the derivative of this function is 14x to the power of 6 negative 8x to the power of 3 plus 15x to the power of 2. This rule that you see here is called polynomial rule of differential calculus. You understand? Okay, it is called polynomial rule of differential calculus. Here, the term is differentiated individually. You understand? You differentiate the term individually. Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function fx equals to 3x squared all over 2 minus the square root of x plus 1 over the square root of x. Okay, to find the derivative of this function, don't forget, I told you if you have a function f of x equals to ax raised to the power of n, the derivative of f of x is equals to n multiplied by ax raised to the power of n minus 1. Are you getting it? Or you can put it like this: a multiplied by nx raised to the power of n minus 1. It's still the same thing, okay? So this rule is called polynomial rule. Now, we are going to use the same rule to differentiate this function, okay? The derivative of f of x is equals to, now, differentiate x squared. The derivative of x squared is 2x, right? So I'm going to have 3 times 2x raised to the power of 2 minus 1. Are you getting it? All over 2. Now, don't forget that the square root of x is what? X raised to the power of 1 over 2, right? So for this, I'm going to have minus x raised to the power of 1 over 2. If you want to differentiate this, what are you going to have? 1 over 2 x raised to the power of 1 over 2 minus 1. Is that not it? Because I told you, according to polynomial rule, you're going to use the exponent to which x is raised to. You're going to use it to multiply the coefficient of x. Then the exponent is going to reduce by 1. Are you get what I'm trying to say? You're going to subtract 1 from the power. So here, I'm going to have 1 over 2 x raised to the power of negative 1 over 2. You get it? Because 1 over 2 minus 1 will give us negative 1 over 2. So for this, I'm going to have minus 1 over 2 x raised to the power of negative 1 over 2. Now, plus, please pay attention. 1 over root of x, how do you solve this? 1 all over root of x will be equals to 1 over x raised to the power of what? 1 over 2, right? Now, according to law of indices, if you have 1 over a, it can be written as what? A raised to the power of negative 1, right? And 1 over a squared is a raised to the power of negative 2. So 1 over x to the power of half will give us x raised to the power of negative 1 over 2. Do you understand? So for this, I'm going to have, if you want to differentiate this now, you're going to have minus 1 over 2 multiplied by x raised to the power of minus 1 over 2 minus 1. Do you understand? If you don't understand, listen to the explanation again. The power to which x is raised to is negative 1 over 2. Do you understand? So now multiply this negative 1 over 2 by the coefficient of x. Negative 1 over 2 times x, the power, which is negative 1 over 2, you're going to subtract 1 from the power according to this polynomial rule. Do you understand? So okay, let me even write it, polynomial rule. Okay, so you're going to subtract 1 from the power. Now, negative 1 over 2, please pay attention. Negative 1 over 2 minus 1. LCM 2, right? Minus 1 minus 2, which is what? Negative 3 over 2. Okay? So for this, I'm going to have plus minus 1 over 2, okay, minus 1 over 2 multiplied by x raised to the power of negative 1 over 2 minus 1. Are you getting it? So for this, the derivative of f of x will be equals to 3 times 2x. 3 times 2 is 6. So I'm going to have 6x raised to the power of 2 minus 1. 2 minus 1 is what? 1. So I'm going to have 6x over 2 minus, okay, now, minus 1 over 2 x raised to the power of negative 1 over 2. Now, this negative sign is going to affect this positive sign. So I'm going to have minus 1 over 2 x raised to the power of, now, negative 1 over 2 minus 1. That is what? Negative 3 over 2. So I'm going to have minus 3 over 2 here. Are you getting it? Okay, we are not done. We can still simplify further. The derivative of f of x is equals to now 6x divided by 2. If you divide this 1, 6 divided by 2 will give us 3. So I'm going to have 3 times x, that is 3x. 3x minus, okay. Now, don't forget that, I just want to explain this now. X raised to the power of negative 1 over 2. X to the power of negative 1 over 2 is equals to 1 over root of x. Do you understand? Are you getting it? So here, I'm going to have minus 1 over 2 multiplied by 1 over root of x, because x raised to the power of negative 1 over 2 is 1 over root of x, according to law of indices. Okay, minus, now for this, I'm going to have 1 over 2 multiplied by, now x raised to the power of 3 over negative 3 over 2 will be equals to 1 over x raised to the power of 3 over 2. And don't forget that this can be written as 1 over the square root of x raised to the power of 3. Do you understand? So for this, I'm going to have multiplied by 1 over square root of x raised to the power of 3. Okay, so the derivative of x, the derivative of f of x is equals to 3x minus 1 over 2 root x minus 1 over 2 root x to the power of 3. Okay, so that is the derivative of x. You can see that it is simple. So all you have to do is that just pay attention to the details of the question. And when you look at the structure of the question, the structure of the questions will tell you the rules that you're going to use. Because from this question now, it is evident that the polynomial rule will work. Are you getting it? So let us look at more questions on differential calculus. Okay. Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f of x equals to 3 over 4x to the power of 2 plus 7 over 8x. Okay, how do we differentiate this function? Well, to do that, please pay attention. We can rewrite f of x as this. 3 over 4 multiplied by 1 over x squared. Do you know? Because 3 times 1 will be what? 3. 4 times x squared will be what? 4x squared. Are you getting it? So, plus, now I can rewrite this 7 over 8x as 7 all over 8 multiplied by 1 over x. Are you getting it? Okay, for this, I'm going to have f of x is equals to, now, according to law of indices, 1 over x is equals to x raised to the power of negative 1, right? And also, 1 over x squared is equals to x raised to the power of negative 2. Do you get it? Okay, let's do the same here. I'm going to have 3 all over 4 multiplied by x raised to the power of negative 2, right? Plus 7 all over 8 multiplied by x raised to the power of negative 1. Are you getting it? Okay, from this point, we can have f of x as 3x raised to the power of negative 2 all over 4 plus 7x raised to the power of negative 1 all over 8. Are you getting it? Now, having gotten to this point, we can use the polynomial rule that we have there to differentiate the function that we have. Okay, according to polynomial rule, the derivative of f of x will be equals to, don't forget, you are differentiating the term individually. Do you understand? So for this, I'm going to have 3 multiplied by that. Negative 2 is going to multiply this. I'm going to have times negative 2, x raised to the power of negative 2 minus 1. Are you getting it? The power will multiply the coefficient of x, and the power will reduce by 1. Are you getting it? you are going to multiply the exponent to which x is raised to, multiply that exponent by the coefficient of x, and then subtract 1 from the power. Are you getting it? So for this, I'm going to have this. Negative 2 will multiply 3. Are you getting it? And I'm going to subtract 1 from negative 2. Subtracting 1 from negative 2 is negative 2, negative 1. Do you get it? All this, all over 4, okay, plus 7x raised to the power of negative 1. Differentiate that. You're going to have 7 multiplied by negative 1 times x raised to the power of negative 1 minus 1. Okay, this all over 8. Okay, from this point, I'm going to have the derivative of f of x is equals to 3 times negative 2. That is negative 6. Negative 6 x raised to the power of negative 3 all over 4 plus 7 times negative 1. That is what? Minus 7, right? So let's change this to minus. Minus 7x raised to the power of negative 2 all over 8. Are you getting it? Okay, having gotten to this point, please pay attention. You can reduce this. Okay, f of x, okay, derivative of f of x is equals to, now 2 divided by 4 will give me 2. I'm going to have this 2. Negative 6 divided by 2 will give me negative 3. So I'm going to have negative 3 x raised to the power of what? Negative 3, okay? Minus 7 all over 8 x raised to the power of negative 1, okay, negative 2, okay? The derivative of x will be equals to, now, please pay attention. X raised to the power of negative 3 is equals to 1 over x raised to the power 3, right? And also, x raised to the power of negative 2, x raised to the power negative 2 is equals to 1 over x raised to the power 2 according to law of indices. The same thing that we did here, okay? So derivative of f of x will be equals to minus 3 multiplied by, okay, minus 3 over 2 multiplied by 1 over x raised to the power of 3, okay? I just separate this fraction, okay? Negative 3 over 2 times x raised to the power of negative 3 is 1 over x raised to the power of 3. So minus 7 all over 8 multiplied by 1 over x raised to the power of 2, okay? The derivative of f of x is equals to minus 3 all over 3x squared. Oh, sorry. Oh, sorry. This should be 2. This should be 2, you know, minus 3 over 2, okay? So this should be 2 as well. 2 times x, 2 times s cubed, that is what? 2x cubed minus 7 times 1 is minus 7. I'm going to have minus 7 all over 8 times x squared. That is what? 8x squared. So therefore, the derivative of the function 3 over 4x squared plus 7 over 8x is equals to negative 3 over 2x cubed minus 7 all over 8x squared. Do you understand? You can see that finding the derivative of a function using the polynomial rule is quite simple when you understand the approach, okay? So let's look at more questions. Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f of x is equals to x squared multiplied by x plus 1 over x. Okay, to find the derivative of this function, let us first open this bracket using x squared. Are you getting it? Let us multiply what we have, the content inside the bracket, by x squared. So for this, I'm going to have f of x is equals to x squared times x. That is what? X raised to the power of 3. Okay, x squared times plus 1 over x. That is plus x squared all over x. Are you getting it? Okay, f of x will be equals to x raised to the power of 3 plus x, because this x that is at the denominator will eliminate one x at the numerator. So for this, I have this. You can see that it is easier to differentiate this, having reduced the function, having simplified the function. So the derivative of f of x will be equals to x, differentiate x cubed. You're going to have 3x raised to the power of 3 minus 2, 3 minus 1 plus 1 times x raised to the power of 1 minus 1, okay? So the derivative of f of x will be equals to 3x squared plus 1, okay? Maybe you are wondering how I got 1. X raised to the power of 0, right? 1 times x is x. 1 minus 1 is 0. I'm going to have x raised to the power of 0. So derivative of f of x will be equals to 3x squared plus 1, because x to the power of 0 is 1. Do you understand? You can see that This one is easy. Okay, let's look at one more question. What if I ask to differentiate f of x is equals to 2x to the power of 3 plus 3 over x? How will you find the derivative of this function? Okay, to take the derivative of this function, you're going to have f of x. Okay, let us rewrite f of x. F of x can be, we can write it as 2x to the power of 3 plus now 3 times 1 over x, right? Because 3 over x can be written as this. And sorry, I've not taken the derivative. F of x will be equals to 2x to the power of 3 plus 3x raised to the power of negative 1 according to law of indices. 1 over x is x to the power of negative 1. So I'm going to have, we've already simplified this. Now let us differentiate. The derivative of f of x will be equals to 2 times 3x to the power of 3 minus 1 plus 3 times negative 1x raised to the power of negative 1, negative 1. Are you getting it? Because you are going to subtract 1 from the power. It doesn't matter whether the power is negative or positive, okay? Anytime you differentiate using polynomial rule, you're going to subtract 1 from the power, okay? So for this, I'm going to have the derivative of x is equals to 2 times 3 is what? 6. I'm going to have 6x to the power of 2 plus 3 times negative 1. That is what? Negative 3, right? I'm going to have negative 3x to the power of negative 1, negative 1. That is what? Negative 2. So negative x to the power of negative 2. For this, I'm going to have f of x, derivative of f of x is equals to 6x squared minus 3 over x squared, because x to the power of negative 2 is 1 over x squared. So negative 3 times 1 over x squared will give us negative 3 over x squared. You can see that it is quite simple. It is easy when understanding is factored in what you are doing, okay? Now let's look at one more question here. What if you are given f of x? F of x is equals to 2 root x minus 3 over root x. How will you find the derivative of this function? Okay, it is simple. Don't forget that root x, the square root of x is equals to x raised to the power 1 over 2, right? So let us rewrite the polynomial function. let us rewrite the function fx. Fx is equals to 2 times x raised to the power of 1 over 2 minus 3 over 1 times 1 over x raised to the power of negative x raised to the power of 1 over 2. Are you getting it? What I have here is still the same thing. 3 over 1 is still 3, right? 3 times 1 will give me 3, right? Yes. 1 times root x will give me root x. Are you getting it? So if you multiply this by this, you're still going to have 3 over root x. Okay? For this, I'm going to have f of x is equals to 2x raised to the power of 1 over 2 minus 3 multiplied by x raised to the power of negative 1 over 2. It's simple. Let me tell you something. Indices is crucial in simplifying, in dealing with questions of this kind, okay? So if you are weak in indices, kindly check the playlist on this channel. You are going to see many soft examples which can help you to understand the concept, okay? So I just use the law of indices here. 1 over x to the power of 1 over 2 can be written as x raised to the power of negative 1 over 2. Do you understand? Now, it is easier to differentiate it now. For this, I'm going to have the derivative of f of x will be equals to 2 multiplied by 1 over 2 x raised to the power of negative 1 over 2. Okay, because 1 over 2 minus 1 will give me negative 1 over 2. Okay, let's do it step by step. 1 over 2 minus 1. Okay, minus 3 times negative 1 over 2 x raised to the power of negative 1 over 2 minus 1. Okay, for this, I'm going to have the derivative of f of x will be equals to, now these two will eliminate these two. Are you getting it? So I'm left with what? 1. 1 times x raised to the power of 1 over 2 minus 1. 1 over 2 minus 1 will give me negative 1 over 2. That is half minus 1. So I'm going to have x raised to the power of negative 1 over 2 minus, now, negative 3 times negative 1. That is what? Positive 3. So I'm going to have positive 3 all over 2 x raised to the power of negative 1 over 2 minus 1. That is what? Minus 3 over 2. Minus 3 all over 2. Do you understand? Okay, having gotten to this point, you can still proceed to simplify. For this, I'm going to have now x raised to the power of negative 1 over 2 is 1 over x raised to the power of 1 over 2, law of indices, okay, plus 3 over 2 times, now x raised to the power of negative 3 over 2 can be written as what? 1 over x raised to the power of 3 over 2. You can see that it is simple. So just simplify it step by step. Now, for this, I'm going to have the derivative of f of x is equals to, now x raised to the power of 1 over 2 can be written as square root of x. It's still the same thing. Plus 3 times 1 is what? 3. 2, okay. Now x raised to the power of, x raised to the power of 3 over 2 can be written as square root of x raised to the power of 3, okay. Now for this, I'm going to have 3 times 1, 3. 2 times x raised to the power of 3 over 2. That is what? 2 root x raised to the power of 3. You can see that it's still the same thing. So anytime you encounter a question, do not fear, okay? Just remember the law. When you remember the law, engage the law to solve the question, and you will arrive at an answer that is correct, okay? So you can see we just simplify 3 questions at a time. Let us look at more work example on differential calculus, okay? Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f of x equals to 1 over root x minus x squared. Oh, minus 1 over x squared. Okay, to solve this question, let us rewrite f of x as 1 over x raised to the power 1 over 2 minus 1 over x squared. F of x can be written as x raised to the power negative 1 over 2 minus x raised to the power negative 2, okay? F of x, okay, differentiate. I'm going to have negative 1 over 2 x raised to the power negative 1 over 2 minus 1, okay, minus multiply by negative 2 x raised to the power minus 2 minus 1. Do you understand? There is an invisible 1 at the coefficient of this x. Are you getting it? So negative 1x is still the same thing as negative x. Do you understand? So I multiply that negative 1 by the exponent of x. So x is raised to the power of negative 2. Negative 1 times negative 2. And then we're going to subtract 1 from the power. So I have negative 2 minus 1. Okay, having gotten to this point, the derivative of f of x is equals to negative 1 over 2 x raised to the power of negative 3 over 2 minus 1 times minus 2. What are you going to have? I'm going to have plus 2x raised to the power of minus 3. Okay, so simplify further. Derivative of f of x is equals to negative 1 over 2 multiplied by, now x raised to the power of negative 3 over 2 can be written as 1 over x raised to the power of 3 over 2. Do you understand? Plus 2 multiplied by x raised to the power of negative 3 can be written as 1 over x raised to the power of 3. So the derivative of f of x will be equals to negative 1 times 1. What are you going to have? That will be negative 1. So I'm going to have negative 1 all over 2 times x to the power of 3 over 2. And don't forget, x to the power of 3 over 2 is equals to square root of x raised to the power of 3, okay? So I'm going to have negative 1 all over 2 root x to the power of 3. Okay? Then put the addition sign. 2 times 1, that is 2. 2 all over x raised to the power of 3, okay? So the solution to, the derivative of f of x equals to 1 over root of x minus 1 over x squared is negative 1 over 2 root x raised to the power of 3 plus 2 over x raised to the power of 3, okay? So that is the solution to that question, okay? Let's consider this question as well. We have, find the derivative of the function y equals to x to the power of 9 minus 1 over x to the power of 9. Okay, to do this, let us rewrite the function as this: x raised to the power of 9 minus x raised to the power of minus 9. Do you know? Because 1 over x to the power of 9 can be written as x to the power of negative 9, okay? Now, it is easy to differentiate this function. The derivative of y, this derivative that you see here can be also written as dy over dx. You understand? Okay, dy all over dx. And you can also use this. You can use this. It's still the same. Okay, dy over dx is 9x raised to the power of okay, let's solve it step by step. 9 times x raised to the power of 9 minus 1 minus 1 times negative 9 raised to the power of x raised to the power negative 9 negative 1. Do you understand? Okay. 9 times 1x. You can put 1 if you like, but it's still the same. Are you getting what I'm trying to say? The only reason why I'm including 1 here is because I'm introducing the negative, because of the negative sign. Do you understand? So the y all over the x is equals to 9x raised to the power of 8 plus 9 x raised to the power of minus 10. Do you understand? Okay, the y all over the x is equals to 9x raised to the power of 8 plus 9. Now, 9 over 1 multiplied by 1 over x raised to the power of 10. Do you know? Because 1 over x to the power of 10 can be written as x raised to the power of negative 10. Do you understand? Law of indices. Okay, so the y all over the x is equals to 9x raised to the power of 8 plus 9 times 1 is what? 9. 1 times x to the power of 10, that is what? X to the power of 10. So the derivative of the function y equals to x to the power of 9 minus 1 all over x to the power of 9 is this. Do you get it? Okay, let us proceed to the next question. We are asked to find the derivative of the function f of x equals to 1 over x squared plus 2 over root x plus 3x. Okay, it is easy to do this. Let us rewrite f of x as this. F of x equals to, now, okay, let's do it step by step. 1 over x squared plus 2 over x raised to the power of 1 over 2 plus 3x, okay? F of x is equals to x raised to the power of negative 2 plus 2x raised to the power of negative 1 over 2 plus 3x. Do you understand? Okay? Now, it is easy to differentiate this function now. For this, I'm going to have the derivative of f of x is equals to, now, differentiate x raised to the power of negative 2. I'm going to have negative 2 x raised to the power of negative 2 minus 1. Do you understand? Okay, now differentiate 2x raised to the power of negative 1 over 2. I'm going to have 2 multiplied by 1 over 2. Oh, sorry. 2 multiplied by negative 1 over 2 x raised to the power of negative 1 over 2 minus 1. Are you getting it? Okay, now differentiate 3x. We are going to have plus 3 multiplied by x raised to the power of 1 minus 1, because the power to which, okay, let's just put it, multiplied by 1x raised to the power of 1 minus 1. I'm going to have the derivative of f of x is equals to negative 2x raised to the power of minus 3, okay, plus, now this negative, these 2 has cancelled these 2, so I'm left with what? Minus, oh god, I'm coming. Okay, having gotten to this point, then simplified, I'm going to have the derivative of f of x will be equals to negative 2x raised to the power of minus 3. Okay, now these 2, we cancel these 2, so I'm going to have negative 1. So I'm going to have minus 1x is also the same thing as what? Minus x, right? So I'm going to have minus x raised to the power of minus 1 over 2 minus 1. That is what? Negative 3 over 2 plus, okay, x raised to the power of 1 minus 1. That is what? X raised to the power of 0. And x to the power of 0 is 1. So 1 times 1 is 1. 1 times 3 will give us 3. So I'm left with what? Plus 3. Okay. The derivative of f of x will be equals to minus 2 multiplied by 1 over x to the power of 3. Do you know that x to the power of negative 3 can be written as this? Law of indices. Minus 1 over x raised to the power of 3 over 2. Are you getting it? Plus 3. Okay. The derivative of f of x will be equals to negative 2 all over x to the power of 3 minus 1 over the square root of x raised to the power of 3 plus 3. So the derivative of the function f of x equals to 1 over x to the power of 2 plus 2 over root x plus 3x is negative 2 over x to the power of 3 minus 1 over root of x to the power of 3 plus 3. Do you understand? Okay, so that is the solution to that question. Let's look at more work example on differential calculus, okay? Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f(x) equals to, f of x equals to x squared plus 1 raised to the power of 2 multiplied by 3x squared plus 2. Okay, to solve this question, you see, don't forget what I told you. The structure of a question will tells you the rule that you're going to employ. In differential calculus, there are various rules One of it is what we have been using since, which is polynomial rule. There is still chain rule. There is quotient rule. In differentiating this function, you can do it in two ways. You understand? You can expand this bracket, but expanding bracket is a bit tedious. You understand? So, and I'm going to use chain rule and product rule to differentiate this function. Okay, so I want you to pay attention. Do you understand? Okay, now this function has two parts. Do you know? This function f of x has two parts, and the first part is x squared plus 1 to the power of 2, while the second part is 3x squared plus 2, right? Okay, so we can make use of chain rule, we can make use of product rule to differentiate this function because we have a function that has two parts, and these two parts are multiplying each other. Do you understand? Okay, so for this, the first part, let u equals to the first part and v equals to the second part. Do you understand? Let u equals to the first part. The first part of this function is x squared plus 1 to the power of 2, while the second part is 3x squared plus 2. Are you getting it? So set u equals to x squared plus 1 and v equals to 3x squared plus 2. Okay, don't forget the square. So now, according to product rule, please pay attention. According to product rule, if you have a function f of x or f of anything, let's use f of x equals to u and v, the derivative of f of x will be equals to, you keep the first part of the function, you keep it constant. Are you getting what I'm trying to say? You keep the first part of the function, you keep it constant. That is, you are not going to touch it. You're not going to differentiate it. So you keep it constant. Then you are going to differentiate the second part of the function. The second part of this function is what? Is v. So I'm going to have u multiplied by the derivative of v plus, now you are going to keep the second part of the function, which is v. You are going to keep it constant and differentiate the first part. Do you get it? So for this, I'm going to have plus v du. This rule that you see here is called the product rule of differential calculus. Are you getting it? And it is used when we have two or more functions. I mean, when we have a function that has two or more parts, and these parts are multiplying each other. So we engage this rule. Do you understand? Okay, now let's go back to the question. U is the first part, V is the second part. Now, if you look at this U, listen to me carefully. This U that you see here, if you look at it very well, you will discover that it has a function inside. We have a function inside the bracket, which is what? X squared plus 1. And this function is raised to a power, which is 2. So let us go. For this, I'm going to have U equals to x squared plus 1 raised to the power of 2. You can use chain rule to differentiate this function. But because, listen to me carefully. All these things I'm solving, we've already done many classes on it. Are you getting what I'm trying to say? So I will advise you to check the playlist. Check the playlist on this channel. If you didn't understand how to solve a typical question of this kind, check the playlist on this channel. I've already said, I have many videos under each rule. Are you getting what I'm trying to say? So click on the playlist, differential calculus, and watch all the class that is there. Okay, you can use chain rule to differentiate this function. Are you getting it? But I'm going to expand the bracket and differentiate it. That's what I'm going to do. I'm going to expand this bracket and differentiate. So for this, I'm going to have u equals to x squared plus 1 raised to the power of. Are you getting it? Oh yeah, expand. U equals to x times x squared. That is what? X to the power of 4. X squared times plus 1. That is what? Plus x squared plus 1, right? So u equals to 4. Oh, sorry. X to the power of 4 plus 2x raised to the power of 2 plus 1. Do you understand? So the derivative of u will be what? 4x to the power of 3 plus 4x. Are you getting it? If you differentiate a constant, you're going to have 0. Do you get it? So the derivative of u is 4x to the power of 3 plus 4x. Now, according to this formula, we still need the derivative of v. Okay? Don't forget the rule that we are using. The rule that we are using is quotient rule. Do you understand? I mean, it's product rule. Now, in product rule, you still need polynomial rule, because you can see that what I use here is called polynomial rule. I use polynomial rule to differentiate this function. Okay, so that is why I said when I start this class that this rule that you see here is very, very important as touching differential calculus. So now V equals to 3x to the 3x squared plus 2. Derivative of v is equals to 6x. Okay, 6x. Derivative of v will be 6x. Okay. Now, having gotten the derivative of u and the derivative of v, we can go back to the formula, which is product rule formula, to substitute the value that we have. So the derivative of f of x will be equals to, now, u is what? X squared plus 1 raised to the power of 2. So I'm going to have x squared plus 1 raised to the power of 2 multiplied by sorry, u, x squared plus 1 raised to the power of 2 multiplied by dv. What is the derivative of v? 6x, right? So I'm going to have multiplied 6x plus v. V is what? 3x squared plus 2. So I'm going to have plus 3x squared plus 2 multiplied by du. Du is the derivative of u. So derivative of u is what? 4x to the power of 3 plus 4x. Okay, so I'm going to have multiplied by 4x to the power of 3 plus 4x. Are you getting it? Okay, now, having gotten to this point, you can proceed to expand the bracket. Okay, so I'm going to have derivative of f of x will be equals to, now if you expand this, you're going to have this. Do you understand? If you expand this bracket, you're going to have this. So I'm going to have x squared, x raised to the power of 4 plus 2x raised to the power of 2 plus 1 multiplied by 6x, okay, plus, okay, now let us expand this. 3x squared times 4x cubed, that is what? 12x raised to the power of 5. 12x raised to the power of 5, okay. What I did was that 3 times 4 is what? 12. X raised to the power of 2 times x raised to the power of 3, that is what? X raised to the power of 5. Okay, this 3x squared times 4x, that is 12 plus 12x raised to the power of 3. Okay, let me expand here so that, because of space, let's expand here. 3x squared times this will give me 12x raised to the power of 5, right? Yes. 3x squared times 4x, that is what? Plus 12x raised to the power of 3 plus 2 times 4x raised to the power of 3, that is what? Plus 8x raised to the power of 3, then plus 2 times 4x, that is what? Plus 8x. Plus 8x, okay? So let us add terms that are similar to each other, add them together. I'm going to have 12x raised to the power of 5 plus 20x raised to the power of 3 plus 8x. Do you understand? Because the power of x here and the power of x here is the same, so we can add them together. They are like terms. Do you understand? So 12 plus 8 will give me 20, okay? So I have this. So let us erase this. I'm going to have 12x to the power of 5 plus 20x to the power of 3 plus 8x. Do you understand? Okay, now for this, I'm going to have derivative of f of x will be equals to 6x times x to the power of 4. That is 6x to the power of 5. 6x times 2x to the power of 2. That is plus 12x to the power of 3. 6x times 1, that is what? Plus 6x, okay? Plus 12x raised to the power of 5 plus 20x raised to the power of 3 plus 8x. Do you understand? Okay, having gotten to this point, it is easy because all we need now is to collect like term. Do you understand? So I'm going to have derivative of f of x. Please pay attention. Derivative of f of x will be equals to 6x to the power of 5 plus 12x to the power of 5. What are you going to have? That is 18x to the power of 5. 18x to the power of 5, okay? 12x to the power of 3 plus 20x to the power of 3. What are you going to have? 32x to the power of 3. So I'm going to have plus 32x to the power of 3, then plus 6x plus 8x. What are you going to have? That is plus 14x. So I'm going to have plus 14x. So the derivative of the function f of x equals to x squared plus 1 to the power of 2 multiplied by 3x squared plus 2 is f is 18x to the power of 5 plus 32x to the power of 3 plus 14x That is the solution to that question, okay? You see, listen to me carefully. I can use chain rule to differentiate this function. Are you getting it? But, don't worry. I'm going to solve this question using chain rule. So I want to pay attention, okay? I'm going to solve this question using chain rule. So I want to pay attention. In chain rule, if you have a function that has another function in itself, if you want to differentiate that function, the method that you're going to use is chain rule. Are you getting what I'm trying to say? Chain rule is used to differentiate a function of a function. That is, if you have a function that has another function in itself. A typical example of such function is fx equals to 4x plus 5 raised to the power of 4, because 4x plus 5 is function itself. 4x plus 5 is a function itself. So, in differentiating this function, hello, please pay attention. According to chain rule, dy all over dx equals to dy all over du multiplied by du all over dx. Are you getting it? If you want to find the derivative of a function dy dx, where y is equivalent to the function that you have here. But for this now, I'm going to have dfx all over dx will be equals to dfx all over du multiplied by du all over dx. Do you understand? The reason why it is this is because what I have here now is not y. Are you getting it? It is fx. But this formula is still similar. They are the same. They are not even similar. They are the same. Are you getting what I'm trying to say? The only difference is that because what I have here now is a function f of x, it is not y. Assuming I have y equals to 4x plus 5 raised to power 2, I'm going to engage this. Are you getting it? But now, it is no longer y that I have here. What I have here is f of x. Do you understand? So now, let's go. To differentiate this function, f of x equals to 4x plus 5 raised to the power of 4. The first step is that you have to set u equals to the function inside the bracket. You understand? The function inside the bracket is what? 4x plus 5. So I'm going to have let u equals to 4x plus 5. Do you know? Hence, if u equals to 4x plus 5, f of x will now be equals to u raised to the power of 4, because now u has been equivalent we have set u equals to the function which is inside the bracket. Are you getting it? So f of x will now be u raised to the power of 4. Do you understand? Okay. Now, according to this formula, we need the derivative of f of x with respect to u. Do you know? So I'm going to have the f of x all over du equals to, now, using polynomial rule, if you differentiate u raised to the power of 4, what are you going to have? 4u raised to the power of 3, right? Yes. Okay. Now, according to this formula, I also need the derivative of u with respect to x. So I'm going to have du all over dx, which is equals to differentiate 4x. You're going to have 4, right? And if you differentiate a constant, you're going to have what? 0. So the derivative of u with respect to x is what? Is 4. Okay, now let's go back to the formula. The derivative of f of x all over dx will be equals to the derivative of f of x all over du. Derivative of f of x all over du is equals to 4u raised to the power of 3. So I'm going to have 4u to the power of 3 multiplied by the derivative of u with respect to x. Derivative of u with respect to x is 4. So I'm going to have 4u raised to the power 3 multiplied by 4. You can see that it's simple. So from this point, I'm going to have derivative of f of x. Hello, listen to me carefully. What I have here is still the same thing as this. Are you getting it? You can write the derivative as this, and you can also write the derivative as this. Do you understand? So don't get confused. They are the same. So f of x, derivative of f of x is equals to 4. Now, listen to me carefully. Don't forget that we have already set u equals to what? 4x plus 5, right? So instead of u, I'm going to replace u as 4x plus 5 in this. Hence, I'm going to have 4 multiplied by 4x plus 5 raised to the power of 3 multiplied by 4. You can see that it's simple. Okay, we are not done. Derivative of f of x will be equals to, now, 4 times 4. What is this? That's 16, right? So I'm going to have 16 multiplied by 16 multiplied by 4x plus 5 raised to the power of 3. So that is the final answer to that question, okay? And if you like, you can put it to expand this bracket, but for the sake of simplicity, you can put it like this. Do you understand? Okay, now, The reason why I'm emphasizing on this is because you can see that if you compare this function x squared plus 1 to the power of 2 and 4x plus 5 to the power of 4, you can see that this function itself has a power. So you can also use chain rule to differentiate this function. Are you getting it? Without expanding, when I'm solving this question, okay, when I solved this question back then, I expand the bracket, then I take the derivative of u, right? But you can also use chain rule. Let's go. According to chain rule, if, let's say, please listen, what I want to do now is that I want to differentiate this function to show you that you can use chain rule to differentiate this. You are going to have this. At the end of the day, you are going to have this answer, even without expanding. If u equals to x squared plus 1 raised to the power of 2, and we want to find the derivative of u. Hello? According to chain rule, the first step is that you have to set the function inside the bracket. You have to set it equals to a letter. Are you getting it? So let us use t. Let t equals to x squared plus 1. Are you getting it? Now, if t equals to x squared plus 1, that means that u will be equals to t raised to the power of 2. Is that not it? You can say that it's simple. If u equals to x squared plus 1 raised to the power of 2, and we've already set t equals to the function x squared plus 1, so u will be equals to t raised to the power of 2, right? Yes. Now, du over dx will now be equals to du all over dt multiplied by dt all over dx. Are you getting it? Oh, dt over dx, sorry. Du over dt multiplied by dt all over dx. So now, with respect to this formula, I need the derivative of t and the derivative of u. Derivative of u with respect to t will be equals to what? 2t, right? Yes. And the derivative of t with respect to x will be equals to dt all over dx, which is what? 2x. So from this formula, du all over dx will be equals to du all over dt is what? 2t. So I'm going to have 2t multiplied by dt all over dx. Dt over dx is what? 2x. So I'm going to have multiplied by 2x. Now, don't forget, please pay attention. Don't forget that t is what? X squared plus 1. So I'm going to have 2 multiplied by, instead of t, I'm going to replace t as x squared plus 1. So I'm going to have x squared plus 1 multiplied by 2x, right? So I'm going to have du all over dx is equals to 2 times x squared, that is what? 2x squared. 2 times plus 1, that is what? Plus 2, okay, multiplied by 2x. Do you understand? I first use these two to multiply all the elements, all the terms that I have inside the bracket. So I have this. Then don't forget that this 2x is also multiplying all of them. So I'm going to have du all over dx is equals to 2x times 2x squared. That is what? 4x squared, 4x cubed. Now, 2x times plus 2, that is what? Plus 4x. So the derivative of this function is 4x raised to the power of 3 plus 4x. You can see that it is still the same. We have the same answer, just like when I expand the bracket and I differentiate using polynomial rule, I have this answer, right? Now, when I expand this without expansion, using chain rule directly, you're going to have the same answer. Do you understand? So the reason why I'm emphasizing on this is because you might have a function that you might not, you will not be able to expand it. For example, let's say the power to which this function is raised to is 9. Are you going to be expanding? No. You employ this rule directly. Use chain rule directly. Do you understand? Because expansion sometimes can be tedious. So I'm just emphasizing on that to help you to comprehend it. Now, you might be wondering that according to this formula, I said it is du. I use the fx over du here times du over dx. Then in this place, I use du over dt times dt over dx. The formula is still the same. Are you getting what I'm trying to say? The variable is what changed. Do you understand? The formula is still the same. So take note of that. Now, let's look at the question that we have on the board. We are asked to find the derivative of the function f of x equals to 1 plus x to the power of 3 over 2 multiplied by 1 plus 2x squared, okay? You see, this function as well is, it has two parts. And these two parts, they are multiplying each other. And in solving this question, we are going to use product rule. But you can see that the first part is raised to a power of 3 over 2. So it is not easy to expand this. So in differentiating the first part, you need to use chain rule. Do you understand it now? Yes, you have to use chain rule. Okay. Now, the first step is that let u equals to the first part. This first part of this function is what? 1 plus x raised to the power of 3 all over 2. Do you know? The first part of the function is 1 plus x to the power of 3 over 2. And the second part of the function is 1 plus 2x squared. Okay. Now, when you are done with that, from the formula of product rule, we need to find the derivative of u and the derivative of v. Do you understand? You can easily differentiate v because v is a polynomial function. Do you know? So the v is what? Differentiate 1, you're going to have 0, right? Yes. Differentiate 2x squared, you're going to have 4x. I'm going to have 4x here. So you are done with dv. Now, what of du? Well, to differentiate u, you have to make use of chain rule. And in chain rule, the first step is that you have to set the function inside the bracket. You have to set it equals to a letter. You can use any letter. Are you getting it? You can use any letter. Now, you have to set the function inside the bracket. You have to set it equals to a letter. Now, let us use p, okay? Let p equals to 1 plus x. Are you getting it? So, if p equals to 1 plus x, that means that u will be equals to p raised to the power of 3 over 2. You can see that it's simple. In this case, I make use of t. So, it is the variable that changed. The formula is still the same. Now, du all over dx. Don't forget that our goal is to find du with respect to x, right? Do you know? Du over dx will be equals to du all over dp multiplied by dp all over dx. Are you getting it? Du over dx will be equals to derivative of u with respect to p multiplied by the derivative of p with respect to x. Are you getting it? So, I've not done anything. Now, if p equals to 1 plus x, let's look for dp over dx. dp all over dx will be equals to differentiate 1, you're going to have 0 because 1 is a constant. Differentiate x, you're going to have 1. Okay. Now, let's look for du over dp. du with respect to p, derivative of u with respect to p will be equals to, now, don't forget, according to polynomial rule that we learned in the beginning of this class, you're going to multiply the power to which the p is raised to. I'm going to have 3 all over 2 multiplied by p raised to the power of 3 over 2 minus 1. Is that not it? Yes. So I'm going to have du all over dp equals to 3 all over 2 p raised to the power of 3 over 2 minus 1. That is what? 1 over 2. Yes, you can do it. 3 over 2 minus 1, you're going to have 1 over 2. So from this point, please pay attention. Du all over dx will be equals to du over dp. Du all over dp is what? 3. Please pay attention. 3 over 2 p raised to the power of 1 over 2. 3 all over 2 p raised to the power of 1 over 2 multiplied by dp over dx. dp over dx is what? Is 1. Are you getting it? So I'm going to have multiplied by 1. You can see that it's simple. Okay, now having gotten to this point, du all over dx will be equals to 3 over 2 multiplied by p. Now, don't forget that p is what? 1 plus x, right? So I'm going to have 1 plus x raised to the power of 1 over 2. Now, if you multiply this by 1, you're still going to have the same thing, right? So ignore that. Now, so the derivative of u with respect to x is this. So according to product rule, listen, according to product rule, derivative of x is u multiplied by derivative of v plus v multiplied by the derivative of u. Do you understand? So I'm going to have the derivative of f of x is equals to, where is u? U is 1 plus x to the power of 3 over 2. So I'm going to have 1 plus x to the power of 3 over 2 u dv. Derivative of v is what? 4x. So I'm going to have multiplied by 4x plus, now, v is what? 1 plus 2x squared. Are you getting it? V is 1 plus 2x squared. So I'm going to have plus 1 plus 2x squared multiplied by du. Du is what? 3 over 2 multiplied by x plus 1 over 2. So I'm going to have 3 over 2 root 1 plus x, because root of 1 plus x is what? 1 plus x to the power of half. Do you understand? So now, having gotten to this point, The derivative of this function is this. So, and you can also rewrite it. Hello. If you want to rewrite it as this, it's simple. You can write it as this. Root of 1 plus x raised to the power of 3 multiplied by 4x plus, okay, 3 over 2 root of x, okay, root of 1 plus x, sorry, 1 plus x multiplied by 1 plus 2x squared. Sorry, I'm coming. 1 plus 2x squared. 1 plus 2x squared, okay? So you can rewrite your answer as this. Do you understand? So that is the solution to that question. If you want to learn more on all the rules in differentiation, such as polynomial rule, power rule, chain rule, and product rule, function of a function, and logarithmic differentiation, implicit, please kindly check the playlist on this channel. Check the playlist, differential calculus, and click on the video that you want to watch. I've already separated the video. I get what I'm trying to say. So watch those classes to have a comprehensive knowledge on what we are doing, because this is just a revision class, okay? So we are asked to find the derivative of the function f of x equals to x plus 1 to the power of 2. Okay, in solving this question, the best method to use is to use the chain rule of differential calculus. You understand? So in chain rule, the first step is that you have to set u equals to the function inside the bracket. Are you getting it? So I'm going to have u equals to x plus 1 over x, right? You see? You can use any letter. Are you getting what I'm trying to say? You can use any letter of your choice, but I make it of u. So don't say because I'm using u, you also want to use u, or it is compulsory that you use u as the letter. Are you getting what I'm trying to say? You can use any letter that you want. So let u equals to the function inside the bracket. The function inside this bracket is what? X plus 1 over x. Are you getting it? That means that f of x will be equals to u raised to the power of 2, right? Because this function now is u. Do you understand? Okay, according to chain rule, just like what we did in the last class, the f of x all over the x will be equals to the f of x all over the u multiplied by the u all over the x. Do you understand? Oh, sorry, all over the x. So from this point, I need the derivative of u with respect to x, and I also need the derivative of f of x with respect to u. Do you understand? So let's go. The derivative of f of x, sorry, with respect to u will be equals to, now, if you differentiate u squared, you're going to have 2u, right? You're going to have 2u here. Now, u can be written as u equals to x plus x raised to the power of -1, right? Now, the u all over the x will be equals to, if you differentiate x, you're going to have 1. So I'm going to have 1 plus, if you differentiate x raised to the power of -1, you're going to have -1x, or negative x raised to the power of -2. Are you getting it? If you didn't understand, listen. U equals to x plus x raised to the power of -1. The u all over the x will be equals to 1 plus -1 times x raised to the power of -1 minus 1, right? So this will give me 1 plus, okay, 1 minus x raised to the power -2, which is still the same. Do you understand? Okay, now having gotten the value of derivative of u with respect to x and the derivative of f of x with respect to u, we can proceed as follows. Derivative of f of x with respect to x will be equals to derivative of f of x with respect to u. That is what? 2u. So I'm going to have 2u multiplied by derivative of u with respect to x. That is what? 1 minus x raised to the power of -2. So I'm going to have multiplied by 1 minus x raised to the power of -2. Okay. Now, the derivative of f of x with respect to x will be equals to 2 multiplied by, what is u? Don't forget that u is x plus x raised to the power of -1, or x plus 1 over x. You can use any one that you like. I'm going to use x plus 1 all over x. Then this multiplied by 1 minus x. Now, x raised to the power of -2 can be written as what? 1 over x squared. So I'm going to have this over 1 over x squared. Okay? Now, please pay attention. derivative of f of x with respect to x is equals to, now open the bracket, I'm going to have 2x plus 2 all over x multiplied by 1 minus 1 all over x squared. Okay, well, you can still expand the bracket. Okay, you can expand the bracket. Derivative of f of x with respect to x equals to 2x plus 2 raised to the power of x power negative 1 multiplied by 1 minus x raised to the power negative 2. Okay, if you like, you can expand the bracket, and then you're going to get your answer. Do you understand? Okay, let's look at the next question. We are asked to differentiate the function f of x equals to the square root of x multiplied by x plus 1. Okay, to solve this question, let us rewrite f of x as this: the square root of, okay, x times x will give me what? X squared. X times plus 1, that is what? Plus x. So, okay, f of x can also be written as x squared plus x raised to the power of what? 1 over 2, right? Okay. Now, having gotten to this point, we can use the chain rule of differential calculus to differentiate this function, because this function inside the bracket is raised to a power which is half. Do you understand? So, according to chain rule, let any letter equals to the function that you have inside the bracket. What you have inside the bracket here, set it to be equals to any letter. Let us use a. Let a equals to what? X squared plus x. Are you getting it? So f of x will be equals to a raised to the power of what? 1 over 2. Because now a has been equals to, we have already equate a to x squared plus x, x squared plus x. So now derivative of f of x will be equals to derivative of f of x with respect to a multiplied by derivative of a with respect to x. Do you understand? Okay, from this point, I'm going to have the a all over the x will be equals to differentiate x squared. You're going to have 2x, okay? 2x. Differentiate x, you're going to have 1. So I'm going to have 2x plus 1. Now, back to this. Differentiate f of x with respect to a. You're going to have the f of x all over the a equals to, now, if you differentiate a raised to the power of 1 over 2, you're going to have 1 over 2a raised to the power of negative 1 over 2. Do you understand? Because now you're going to subtract 1 from half. Are you getting it? You're going to subtract 1 from half. 1 over 2 minus 1 will give you negative 1 over 2. Do you understand? Okay? Polynomial rule. Now, having gotten to this point, derivative of f of x is equals to derivative of f of x with respect to a, which is what? 1 over 2 times a raised to the power of negative 1 over 2. 1 over 2 multiplied by a raised to the power of negative 1 over 2 multiplied by the a over the x. The a over the x is what? 2x plus 1. So I'm going to have multiplied by 2x plus 1. Now, having gotten to this point, we can still proceed. I'm going to have, now, don't forget that a has been, we have already said a is what? X squared plus x. A is x squared plus x. Don't forget. So I'm going to have 1 over 2. Instead of a, I'm going to replace it as x squared plus x. I'm going to have x squared plus x raised to the power of negative 1 over 2 multiplied by 2x plus 1. Are you getting it? Okay. Derivative of f of x is equals to 1 over 2 multiplied by 1 over x squared plus x raised to the power of what? 1 over 2. Do you know? Because this is raised to a negative sign, it's going to be the inverse of what I have here. Do you understand? Okay. So that is law of indices. And this will also multiply 2x plus 1. Okay. Derivative of f of x will be equals to 1 times 1 is what? 1. 2 times x squared plus x raised to the power of half. That is what? 1 all over 2 roots x squared plus x multiplied by 2x plus 1. Do you understand? Okay, 2x plus 1 times 1. That will give us derivative of f of x will be equals to 2x plus 1 all over 2 roots x squared plus x. So that is the answer to that question. Do you understand? Okay. Well, you can attempt this by yourself. I'm very sure you can do it. Okay. You can attempt it by yourself. and then when you are done, play the video to check whether your answer is correct or not. Okay, let's solve it together. To solve this question, let's rewrite f of x. F of x can be written as x raised to the power of 1 over 2 multiplied by x plus 2x raised to the power of 2 plus 3x raised to the power of 3, right? Okay, now let us use this x raised to the power of half to multiply every term that we have in the bracket. So for this, I'm going to have f of x will be equals to, okay, x raised to the power of half multiplied by x. I'm going to have x raised to the power of half plus 1, okay? Now, x raised to the power of half multiplied by plus 2x squared. I'm going to have plus 2x raised to the power 2 plus half, right? Then x raised to the power of half multiplied by 3x cubed. I'm going to have plus 3x raised to the power of 3 plus half. Do you understand? Okay. Now, having gotten to this point, I'm going to have f of x is equals to, now, x raised to the power of 1 over 2 plus half. What are you going to have? You're going to have 3 over 2 plus, now, 2x raised to the power of 2 plus 1 over 2. What are you going to have? You're going to have 5 over 2, right? Yes. 5 all over 2. Okay. Plus 3x raised to the power of, now, 3 plus 1 over 2. Hello. 3 plus half. 3 plus half. What are you going to have? You're going to have 7 over 2, right? You're going to have 3x raised to the power 7 all over 2. Now, having gotten to this point, the next step is that we are going to differentiate each term individually. Do you understand? So let us start with this. Derivative of f of x will be equals to 3 all over 2 x raised to the power of 3 over 2 minus 1 plus 2 multiplied by 5 all over 2 x raised to the power of 5 over 2 minus 1, then plus 3 multiplied by 7 all over 2 x raised to the power of 7 over 2 minus 1. Are you getting it? Okay. Now, derivative of f of x will be equals to 3 all over 2 x raised to the power of 3 over 2 minus 1. That will be what? 1 over 2, right? So I'm going to have 1 over 2 plus, now these 2 can eliminate these 2. So I'm left with what? 5. So I'm going to have 5x raised to the power of 5 over 2 minus 1. What are you going to have? That is 3 over 2, sorry. 3 over 2. Then 3 over 2 times 7. What are you going to have? 27, right? 3 times 7, that is 21. So I'm going to have 21 all over 2 x raised to the power of 7 over 2 minus 1. That is 5 over 2. Okay. If you didn't understand, let me know, okay? It is simple, okay? It is simple. The first step is that I rewrite square root of x as x raised to the power of 1 over 2. Then I use it to multiply every time that I have in a bracket. Do you understand? And according to law of indices, because I have x times x, this x is raised to a power of 1. So I'm going to add the power. 1 over 2 plus 1 will give me 3 over 2. Okay? And the same thing I did for the rest. Now, let us simplify. For this, I'm going to have derivative of f of x will be equals to 3 over 2 root of x plus 5 root of x raised to the power of 3 plus, here I'm going to have 21 all over 2 root of x raised to the power of 5. Okay, you can see. So that would be, you can also take the LCM, but you can leave your answer like this. Do you understand? And if you want to take the LCM, you're going to have f of x be equals to, the LCM will be 2. So you're going to have 3 root x plus 10 root x raised to the power of 3 plus 21 root x raised to the power of 5. Do you understand? Okay. So the solution, the derivative of the function f of x equals to the square root of x multiplied by x plus 2x squared plus 3x cubed is this. Okay. Okay, let's consider the following question that we have on the board. We are asked to find the derivative of the function f of x equals to x squared plus 1 all over x. I'm going to differentiate this function using two methods. The first method is that I'm going to simplify it and then I'm going to differentiate this using the polynomial rule. And the second method, I'm going to make use of the quotient rule to differentiate the function to check whether you're going to have the same answer. Okay, let's start with the first method. Let us rewrite f of x. F of x can be written as x squared all over x plus 1 all over x. You understand? I just separate the fraction. If you take the LCM of this fraction, you are still going to have what you have here. Do you understand? Okay, f of x is equals to, now, x squared divided by x. That will give us x. So I'm going to have x plus 1 over x can be written as x raised to the power of negative 1. Okay, having gotten to this point, we can differentiate the function using the polynomial rule. I'm going to have f of x derivative will be equals to, differentiate x, you're going to have 1, okay? And if you differentiate x to the power of negative 1, you're going to have plus multiplied by minus 1 times x raised to the power of minus 1 minus 1, right? Okay, I'm going to have the derivative of x, f of x, equals to 1 minus x raised to the power of negative 2. Do you know? So I'm going to have the derivative of f of x is equals to 1 minus 1 over x raised to the power of 2, okay? So that will be the derivative of x. Now, let us use the quotient rule to differentiate this function, okay? Now, quotient rule is used to differentiate a function that is in quotient form. You understand? A function that is in quotient form, in that case, we're going to engage the quotient rule to differentiate the function. Are you getting it? Now, the numerator of this function is u, and the denominator, you call it v. You call it v. According to the quotient rule, derivative of f of x is equals to v multiplied by the derivative of u minus u multiplied by the derivative of v all over v squared, okay? This rule that you see here is called quotient rule. Don't forget, you only use quotient rule when the function that you're asked to differentiate is in quotient form. Do you understand? If the function that you're asked to differentiate is having a division, you can make use of quotient rule to differentiate the function. Do you understand? Okay, now let us proceed. For this, I'm going to have u is equals to what? The numerator. U is the numerator, x squared plus 1, and v is the denominator, which is what? X. Are you getting it? Okay. Now, from this formula, we need to take the derivative of u. Do you understand? And the derivative of u will be equals to 2x, right? Now, from this formula also, we still need the derivative of v. So, the derivative of v will be equals to what? If you differentiate x, you are going to have 1. So, I'm going to have 1 here. Okay, the next step is that you just have to substitute the value of what you have here into this formula. Are you getting it? And then simplify. So the derivative of f of x is equals to v. V is what? X. I'm going to have x multiplied by du. Derivative of u is what? 2x. So I'm going to have x multiplied by 2x minus u. U is what? U is x squared plus 1. So I'm going to have minus x squared plus 1 multiplied by the derivative of v. Derivative of v is what? Is 1. So I'm going to have times 1. Okay, times 1. Okay, all over v squared. V squared. V is what? X. So the square of x will be what? X squared. Do you understand? Okay, so derivative of x will be equals to x times 2x. That will be what? 2x squared. 2x squared minus, okay, x squared plus 1 times 1. That will also give us x squared plus 1. Okay, the negative sign is going to affect both the x squared and plus 1. So I'm going to have minus x squared minus 1, okay? All of this all over x squared. Please pay attention. For this now, I'm going to have derivative of f of x is equals to 2x squared minus x squared. That is what? That will give me x squared. So I'm going to have x squared minus 1 all over x squared, okay? So derivative of f of x will be equals to, now if you separate this fraction, you're going to have x squared all over x squared minus 1 all over x squared, right? So the derivative of f of x will be equals to 1 minus 1 all over x squared. So the solution to this question using the quotient rule is this. Are you getting it? So we still have the same answer. Are you getting what I'm trying to say? Okay. Now, let's look at the next question. We are asked to find the derivative of f of x equals to 2x squared minus 3 over x multiplied by 3x squared minus 2x, okay? Now, in this question, you can see that this function has two parts. And these two parts, they are multiplying each other. That is, the sign between the first part and the second part is a product sign. So the rule to differentiate this function is product rule. Do you understand? So I'm going to let u equals to the first part, u equals to the first part. And the first part of this function is this, while the second part is this. U equals to 2x squared minus 3 over x. So I'm going to have 2x squared minus 3 over x. And the second part, I'm going to set it equals to v. So v equals to 3x squared minus 2x. Okay, when you're done with that, according to product rule, you still need the derivative of u and v. Are you getting it? So I'm going to take the derivative. Derivative of u equals to 4x minus, okay, for the sake of clarity, let me rewrite u. U can be written as u equals to 2x squared minus 3x raised to the power of negative 1, right? Okay, let's take the derivative of u. I'm going to have 4x plus, I've forgotten. I will explain, okay? Minus 3 times minus 1 x raised to the power of minus 1 minus 1. Do you know? According to polynomial rule that I taught you. So if you differentiate negative 3x to the power of 1, you're going to have negative 3 times negative 1 times negative 1 minus 1. Okay? So for this, derivative of u will be equals to 4x minus 3 times negative 1. That is what? Plus 3. I'm going to have plus 3x raised to the power of negative 2. Okay? Derivative of v will be equals to 6x minus 2, right? Yes. Now, product rule. Derivative of f of x is equals to u dv plus v du. Okay? Now, u is what? U is 2x squared minus 3x raised to the power of minus 1. So I'm going to have 2x squared minus 3x raised to the power minus 1 multiplied by dv. What is the derivative of v? Derivative of v is 6x minus 2. So I'm going to have multiply 6x minus 2, then plus, now v. V is what? 3x squared minus 2x. I'm going to have 3x squared minus 2x multiplied by du. Derivative of u is what? 4x plus 3x to the power of minus 2. So let me erase this. Multiply by 4x plus 3x to the power of negative 2, okay? Now, all we need to do now is just to expand. Are you getting what I'm trying to say? So let us expand. 3x and 2x squared times 6x. I'm going to have 2x squared times 6x. That is 12x to the power of 3, right? Yes. 2x squared times negative 2. 2x squared times negative 2. That is negative 4x to the power of 2. Okay? Negative 3x raised to the power of negative 1 times 6x. That is what? Minus 18 x raised to the power of 0. Are you getting it? Because according to law of indices, if you are multiplying negative 3x raised to the power minus 1 times 6x, negative 3 times 6, that is what? Minus 18, right? Now, x raised to the power of negative 1 times x, that will be what? X raised to the power of minus 1 plus 1, right? So you're going to have negative 18x raised to the power 0. And x raised to the power of 0 is what? 1. Minus 18 times 1, that is what? Minus 18. So I'm going to have minus 18 here. Do you understand? Okay. Now, negative 3x raised to the power of negative 1 times 2, that will be what? Plus 6x raised to the power of minus 1. Are you getting it? Okay. Now, the expansion of the first bracket is this. Now, let us proceed to the second bracket. For the second bracket, we're going to have plus 3x squared times 4x, that is 12x to the power of 3. 12x to the power of 3, okay? 3x squared times 3x to the power of negative 2. I'm going to have 9x to the power of 0, okay? Please pay attention. Plus 9x, maybe I should do the solution here. Listen, 3x squared times 3x to the power of negative 2. 3 times 3 is 9. X raised to the power of 2 plus minus 2. 9x raised to the power 2 minus 2. 9x raised to the power 0, which is what? 9. Because x to the power of 0 will give me 1. So 9 times 1 is what? 9. Do you understand? Okay. So 3x squared times 3x to the power of negative 2, that will be 9. Do you understand? Now, negative 2x times 4x, that is what? Negative 8x. Negative 8x. Negative 2x times plus 3x to the power of negative 2. Negative 2 times plus 3, that is what? Minus 6, right? X times x raised to the power of negative 2, that is x raised to the power of negative 1. I'm going to have minus 6x raised to the power of negative 1. Do you understand? Okay. Now, for this, I'm going to have derivative of x will be equals to, let's collect like terms. 12x raised to the power of 3 minus 4x raised to the power of 2 minus 18 plus 6x raised to the power of negative 1 plus 12x raised to the power of 3 plus 9 minus 8x minus 6x raised to the power of negative 1. Are you getting it? Okay. Derivative of f of x will be equals to, now let us collect like terms. I'm going to have 12x to the power of 3 plus 12x to the power of 3. What are you going to have? That is 24x to the power of 3. Okay. 12x to the power of 3. Oh, sorry. Negative 4x squared. Is there any? Okay, there is not. So just put it minus 4x to the power of 2. Okay, we have 6x to the power of negative 1 plus 6x to the power of negative 1 minus 6x to the power of negative 1. That will give us 0. So this eliminates this. Are you getting it? Now, is there any other like term? Oh, I didn't even put x here, sorry. X to the power of 3, okay? Is there another like term? Okay, minus 8x. I'm going to have minus 8x. Then negative 18. Negative 18 plus 9. Negative 18 plus 9 will give us positive, yes, negative 9. Do you understand what I did? I just collected like terms, okay? If you had this and this together, you're going to have 24x to the power of 3, okay? Now, there is no power of x to the power of 2, so I put, I brought negative 4x squared down to this place. Then I checked. I still have negative 8x. So I bring it to this place. I brought it to this place. Then negative 18 plus 9 will give us negative 9. Do you understand? So the derivative of the function f of x equals to this is this. Do you understand? If you have any question, let me know in the comment section, okay? Now, let us look at the third work example that we have on the board. We are asked to find the derivative of the function f of x equals to x squared plus 2x multiplied by x squared plus 1. Okay, how do we take the derivative of the function? Well, you can see that this function also has two parts, just like the one that we did earlier. This function has two parts, and the first part is this, while the second part is this. So let's set the first part equals to u equals to x squared plus 2x, and the second part equals to v, which is x squared plus 1, okay? From product rule formula, we need to take the derivative of u and v. Are you getting it? So I'm going to have derivative of u equals to 2x plus 2, while the derivative of v equals to 2x, right? Now, the derivative of f of x will be equals to, now we have to keep the first part. We have to keep it constant, right? The first part is this. You keep it constant. I'm going to have x squared plus 2x multiplied by the derivative of v, which is 2x, plus, now you have to keep the second part. You have to keep it constant, which is x squared plus 1. So I'm going to have plus x squared plus 1 multiplied by the derivative of u. Derivative of u is 2x plus 2. So I'm going to have multiplied by 2x plus 2. Okay. So for this, I'm going to have derivative of x will be equals to 2x times x squared. That is what? 2x to the power of 3. 2x times plus 4x. That is what? Plus 4x squared. 2x times plus 2x. That will give us plus 4x squared, right? Yes. Okay. Plus 2x times x squared. That is what? Plus 2x squared. I mean, plus 2x to the power of 3. 2x to the power of 3. X squared times 2. That is what? Plus 2x squared. Plus 1 times 2x. That is what? Plus 2x. Plus 1 times plus 2. That is what? Plus 2. Okay. So the next step is that we have to collect like terms. The next step is that you have to collect like terms. So I'm going to have the derivative of f of x will be equals to, now 2x to the power of 3 plus 2x to the power of 3. What are you going to have? That is 4x to the power of 3, right? 4x to the power of 2 plus 2x to the power of 2. That is 6x to the power of 2, okay? Now, Then we are going to have plus 2x here and plus 2. Do you understand? So the derivative of the function f of x equals to x squared plus 2x multiplied by x squared plus 1 is 4x squared plus 6x 4x cubed plus 6x squared plus 2x plus 2. Do you understand? Okay. Let's consider the question that we have on the board. We are asked to find the derivative of the function f of x equals to the square root of 1 plus 2x plus 3x squared all over x squared. Okay, how do we find the derivative of this function? Well, to differentiate this function, it is easy. In differentiating this function, we are going to set u. Okay, let's consider the question that we have on the board. We are asked to find the derivative of, oh God, please, I want you to pay attention, okay? Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f of x equals to the square root of 1 plus 2x plus 3x squared all over x squared. Okay, how do we take the derivative of this function? To take the derivative of the function, we are going to make use of the quotient rule. Are you getting it? Because now we have a function that has both upper part and the lower part. Are you getting what I'm trying to say? We have a function that has a numerator and the denominator. And when you have a function that is in quotient form, the quotient rule is good to solve that question. So the first step is that let u equals to the numerator of the function. The numerator is the square root of 1 plus 2x plus 3x squared. Are you getting it? And let v equals to the denominator of the function, which is x squared. Well, you can make use of any letter. Hello? You can make use of any letter, but I just choose u and v. Now, the next step is that you are going to differentiate both u and v, because according to quotient rule formula, we need the derivative of both the numerator and the denominator. Do you understand? So let's start with u. Don't forget that u can be written as what? 1 plus 2x plus 3x squared raised to the power of 1 over 2, right? Yes. To differentiate u, we are going to make use of chain rule. You understand? Because now we have a function inside the bracket, and this function is raised to a power. Do you understand? So, and chain rule is used to differentiate a function of a function. That is, a function that has another function in itself. Do you understand? So for this, I'm going to have let t equals to the function inside the bracket. What I want to do now is that I want to differentiate this function using chain rule. So to differentiate this function using chain rule, set the function inside the bracket, set it equals to a letter. Are you getting it? So let t equals to the function inside the bracket. The function inside the bracket is 1 plus 2x plus 3x squared. So I'm going to have t equals to 1 plus 2x plus 3x squared. Okay. Now, if t equals to this, that means that u will be equals to t raised to the power of 1 over 2, right? Yes. So for this, differentiate t and u. Let's first start with t. dt all over dx will be equals to, we want to differentiate t with respect to x. dt over dx will be equals to, differentiate 1, you're going to have 0. Differentiate 2x, you're going to have 2. Differentiate 3x squared, you're going to have 6x. So I'm going to have plus 6x. Okay, dt over dx is plus 2 plus 6x. Now, we still need to take the derivative of u with respect to t, because according to chain rule, you are going to multiply the derivative of the outer function and the inner function. You're going to multiply it. You are going to multiply them. That will give you your answer. Are you getting it? The inner function is this, while the inner function is this, while the outer function is this. Are you getting it? So we've already taken the derivative of the inner function. We also need the derivative of the outer function, which is t raised to the power of t raised to the power of 1 over 2. Do you understand? So for this, I'm going to have du all over dt equals to, differentiate t raised to the power of half. I'm going to have 1 over 2 t raised to the power of negative 1 over 2, right? So du all over dx will be equals to du all over dt multiplied by dt all over dx. Do you understand? So for this, I'm going to have du all over dx is equals to, du over dt is 1 over 2 t raised to the power of negative 1 over 2. Do you understand? So I'm going to have 1 over 2 multiplied by t raised to the power of negative 1 over 2 multiplied by dt over dx. the t over the x is 2 plus 6x. So I'm going to have multiplied by 2 plus 6x. Okay, having gotten to this point, please pay attention. Du all over dx will be equals to 1 over 2. Now, don't forget that t is equals to 1 plus 2x plus 3x squared. So instead of writing t, I'm going to replace t as 1 plus 2x plus 3x squared. So for this, I'm going to have multiplied by 1 plus 2x plus 3x raised to the power of 2 raised to the power of negative 1 over 2. Are you getting it? And all of this will multiply 2x. All of these times, multiply 2 plus 6x. Do you understand? So I've not done anything, no. I'm just simplifying what I have on the board. So don't get confused, okay? Now, having gotten to this point, the next step is that I'm going to have du all over dx will be equals to, see, listen to me carefully. What I'm doing now is that I'm just taking the derivative of u equals to this. Are you getting it? I've not done anything. I'm just taking the derivative of u equals to this. So for this, I'm going to have 1 over 2 multiplied by 1 over the square root of 1 plus 2x plus 3x squared, okay? According to law of indices. Are you getting it? So I'm going to have all this multiplied by 2 plus 6x, okay? So du all over dx will be equals to, now 2 plus 6x multiplied by 1, that will be what? 2 plus 6x all over 2 times root 1 plus 2x plus 3x squared. That will be 2 root 1 plus 2x plus 3x squared. Are you getting it? So now, that will be the derivative of u with respect to x. Now, it is still simplifiable. Are you getting it? We can still simplify it. Du all over dx will be equals to, now, factorize 2. You're going to have 2 into bracket 1 plus 3x, right? All over 2 roots 1 plus 2x plus 3x squared. 1 plus 2x plus 3x squared, okay? So du all over dx will be equals to, now this will eliminate this. That will be 1 plus 3x, 1 plus 3x all over the square root of 1 plus 2x plus 3x squared, okay? So du dx, this is the value of du dx. Now, we also need the derivative of v with respect to x. So derivative of v with respect to x will be equals to 2x. Are you getting it? So according to quotient rule, derivative of f of x will be equals to v multiplied by the derivative of u minus u multiplied by the derivative of v, all of this all over v squared, okay? That is the derivative of the second part multiplied by the second part multiplied by the derivative of the first part minus the first part multiplied by the derivative of the second part all over the square of the derivative of the second part. Don't forget that the second part is the denominator. You understand what I'm saying? In quotient rule, the second part of that function is the function that is beneath. Are you getting it? The function that is at the denominator. So now let us, the next step is to plug in all the values that we have. So the derivative of x, f of x will be equals to v. v is what? X squared. So I'm going to have x squared multiplied by the derivative of u. Derivative of u is what? 1 plus 3x all over the square root of 1 plus 2x plus 3x squared. So I'm going to have x squared times 1 plus 3x all over the square root of 1 plus 2x plus 3x squared, okay? Minus u. U is what? U is the numerator, right? And the numerator is what? 1 square root of 1 plus 2x plus 3x squared. So I'm going to have minus the square root of 1 plus 2x plus 3x squared all over, u dv. Derivative of v is what? 2x. So I'm going to have all this multiplied by 2x. All of this over v squared. Don't forget that v is what? X raised to the power of 2. So x raised to the power of 2 squared. Okay, let's put it. X raised to the power of 2 squared. Okay. So we've not done anything. Now, please pay attention. Pay attention. This is where I want to pay attention. I want to simplify the numerator now, okay? I want to simplify the numerator. So for this, I'm going to have derivative of f of x will be equals to, now, x squared times 1, that is what? X squared. So I'm going to have x squared times 3x squared, that is x squared times plus 3x, that is what? Plus 3x cubed. Okay, all of this will be over square root of 1 plus 2x plus 3x squared. Okay, are you getting it? What I did was that I multiplied this x squared by the numerator, you understand? So if you multiply this by this, you're going to have this, and this denominator is here. Now, minus 2x multiplied by the square root of 1 plus 2x plus 3x. 1 plus 2x plus 3x squared. Now, for me, okay, all this all over 1. Now, don't forget that the numerator which we have here is dividing this, right? So I'm going to have, put all this into bracket, divided by x raised to the power of, now, 2 times 2 will give us 4. So I'm going to have x raised to the power of 4. Do you understand? Okay. The numerator is what we have here. Are you getting it? The division sign is here, while the denominator is here. Do you understand? So even let us put over 1, x to the power 4 over 1. Okay. Now the next step is that for this, I'm going to have the derivative of f of x will be equals to, now take the LCM. Please pay attention. Take the LCM. The LCM will be the product of this and this. So I'm going to have square root of 1 plus 2x plus 3x squared as the LCM. Okay. Now this divided by this, that is 1. 1 times this, I'm going to have x squared plus 3x cubed. Okay. Now, square root of 1 plus 2x plus 3x squared divided by 1, that will give me square root of 1 plus 2x plus 3x squared. Now, if you multiply this by this, you're going to have minus 2x multiplied by 1 plus 2x plus 3x squared. Okay. All this multiplied by 1 over x raised to the power of 4. Do you understand? Okay. Now, please, I want you to pay attention. Let's just simplify. It's simple. Having gotten to this point, the next step is that open the bracket. I'm going to have x squared. Derivative of f of x will be equals to x squared plus 3x cubed minus, okay, now 2x times 1, that is what? 2x. So I'm going to have minus 2x. 2x times plus 2x, that is what? Plus 4x squared. Then 2x times 3x squared, that is what? 6x cubed plus 6x cubed. Okay. This all over the square root of 1 plus 2x plus 3x squared, all over the square root of 1 plus 2x plus 3x squared. Okay. Now, x squared times the x raised to the power of 4 times this will give us x raised to the power of 4. Are you getting what I'm trying to say? So now derivative of f of x will be equals to, now use the negative sign to multiply all through the parameters or the terms that are inside the bracket. You're going to have x squared plus 3x raised to the power of 3 minus 2x minus 4x raised to the power of 2 minus 6x raised to the power of 3. Okay. All over x raised to the power of 4 multiplied by the square root of 1 plus 2x plus 3x squared. Okay. So the derivative of f of x will be equals to, now let's see if we can collect like terms. Yes, we can. Plus 3x cubed minus 6x cubed, that will give me minus 3x cubed. Okay. Are you getting it? X squared minus 4x squared, that will give us minus 3x squared. Minus 3x squared. Okay. Then we have negative 2x, that is minus 2x. All over x raised to the power of 4 multiplied by the square root of 1 plus 2x plus 3x squared, okay? Now, for this, I'm going to have derivative of f of x will be equals to, now we can factorize x, are you getting it, at denominator. So I'm going to have x multiplied by negative 3x raised to the power of 2 minus 3x minus 2 all over x raised to the power of 4 multiplied by the square root of 1 plus 2x plus 3x raised to the power of 2, okay? Now, from this point, do you know that this x here can eliminate one x here? So I'm going to have the f of x will be equals to minus 3x raised to the power of 2 minus 3x minus 2 all over. Now, instead of x raised to the power of 4, I'm going to have x raised to the power of 3. So I'm going to have here x raised to the power of 3 multiplied by the square root of 1 plus 2x plus 3x squared, okay? So the derivative of the function f of x equals to the square root of 1 plus 2x plus 3x squared all over x squared is negative 3x squared, negative 3x, negative 2 all over x raised to the power of 3 multiplied by the square root of 1 plus 2x plus 3x squared. Do you understand? Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function f of x equals to 2x squared multiplied by the square root of 2x plus 1. Okay, we can rewrite f of x as 2x squared multiplied by 2x plus 1 raised to the power of 1 over 2, right? Okay, now looking at this function has two parts. The first part is this and the second part is this. So I'm going to differentiate both parts. Are you getting it? Because to differentiate this function now, I have to make use of the product rule. Do you understand? I have to use product rule to differentiate the function. And also, I'm going to have u equals to the first part, 2x squared, and v equals to the second part, which is 2x plus 1 raised to the power of 1 over 2. So for this, I'm going to have derivative of u equals to what? 4x. Are you getting it? Now, this is v. If I want to differentiate v using the chain rule, I'm going to have derivative of v equals to 1 over 2 multiplied by 2x raised to the power of 2x plus 1 raised to the power of negative 1 over 2 multiplied by 2. This will be the derivative using the chain rule. Okay? And I've done more examples on chain rule. So if you want to learn more on chain rule, you can always check the channel. I get what I'm trying to say. Click on the playlist on this channel. I've done more questions on chain rule. So if you want to learn more on chain rule, kindly click on the playlist of this channel. Okay. Now, if you differentiate this using chain rule, this is what you are going to have. Okay. Now, having differentiate u and v according to product rule formula, derivative of f of x will be equals to u, which is what, 2x squared multiplied by dv. dv is the derivative of v. Derivative of v is what? 1 over 2 multiplied by 2x plus 1 raised to the power of negative 1 over 2 multiplied by 2. u dv plus v. v is what? 2x plus 1 raised to the power of 1 over 2. I'm going to have 2x plus 1 raised to the power of 1 over 2 v du. du is 4x, so I'm going to have multiply 4x. Okay, now the derivative of f of x will be equals to, please pay attention, I'm going to have 2x squared. Now these 2x plus 1 all over 2 raised to the power of negative 1 over 2 multiplied by 2 plus 2x plus 1 raised to the power of 1 over 2 multiplied by 4x, right? Okay, let us simplify. I'm going to have f of x derivative will be equals to, these 2 will eliminate these 2, so I'm left with what? X squared all over 1 multiplied by 1 over 2x plus 1 raised to the power of 1 over 2 plus, okay, square root of 2x plus 1 multiplied by 4x times 4x, right? Do you know what I did? Hello? Don't forget that there is 1 2 here, so you can have the 2 times 2. Do you know what I did? these two eliminate these two here, so I'm left with x squared. So I'm going to have x squared all over 1. Are you getting it? And because 2x plus 1 is raised to the power of negative 1 over 2, I'm going to have 1 over 2x plus 1 raised to the power of 1 over 2. Are you getting it? This 2 is here, and this addition sign is here. Now 2x plus 1 raised to the power of half is square root of 2x plus 1, and this multiplied by 4x. Do you understand? Okay, so the derivative of f of x will be equals to 2 times 1 times x squared, that is 2x squared. 2x squared all over the square root of 2x plus 1 plus 4x multiplied by the square root of 2x plus 1. Do you understand? Okay? If you want to take the LCM, you can proceed. The LCM will be, the LCM is square root of 2x plus 1. Okay? I'm going to have 2x squared plus 4x multiplied by 2x plus 1. Do you understand? Okay? If you don't understand, just reverse the video and listen to the explanation again. You will surely understand, because the question, the video is simple. The question is simple. Now, when you get to this point, all you have to do is now is just open the bracket. Are you getting it? Okay, let me proceed here. For this, I'm going to have f of x is equals to 2x squared plus, now 4x times 2x, that is what? 8x squared. 8x squared. 4x times plus 1, that is what? Plus 4x. All over the square root of 2x plus 1. Square root of 2x plus 1, okay? So, derivative of f of x will be equals to 2x squared plus 8x squared, that is 10x squared. 10x squared plus 4 all over the square root of 2x plus 1. So, that will be the final answer, okay? Hello? The final answer is 10x squared plus 4. Plus 4x, sorry. Okay, so when you get to this point, you just take the LCM. The LCM will be the product of this and this. So I have this. This divided by this is 1. 1 times 2x squared, that is 2x squared. Root of 2x plus 1 divided by 1, that is root of 2x plus 1 times this. It will give me 4x times 2x plus 1. Do you understand? So I just open the brackets using this 4x. 4x times 2x will give me 8x squared. 4x times plus 1 will give me 4x. So I collect like terms, I got 10x squared plus 4x. So the derivative of f of x will be this. Do you understand? Okay, let me erase that and then we can proceed to the next question. So the final answer to this is 10x squared plus 4x all over the square root of 2x plus 1. Okay, now let's consider the question that we have on the board. We are asked to find the derivative of f of x equals to 1 plus 2x squared raised to the power of 3 all over x. Okay, to solve this question, we are going to use the quotient rule. Do you understand? But if you look at the numerator, you will discover that we have the function inside the bracket is raised to the power of 3. So in that case, we are going to use the chain rule to differentiate that function. Okay, now set u equals to the function at the top. Are you getting it? The function that is at the top, the numerator, set u equals to it. I'm going to have u equals to 1 plus 2x squared raised to the power of 3, okay? Then the function at the denominator, let it be equals to v. So I'm going to have v equals to x, okay? Now, differentiate u using chain rule. I'm going to have 3 multiplied by 1 plus 2x raised to the power of 2 raised to the power of 2 multiplied by 4x, okay? If you use chain rule to differentiate this function, you're going to have this. Are you getting it? So derivative of u will be equals to 4x times 3. I'm going to have 12x multiplied by 1 plus 2x raised to the power 2 raised to the power 2. Okay? So this is v. Derivative of v will be equals to x. Derivative of x is what? 1. So I've already differentiated both u and v. Now, having gotten to this point, the next step is that you have to just remember the formula of quotient rule. According to quotient rule, f of x, derivative of f of x will be equals to v du minus u dv all over v squared, right? Yes. So derivative of x will be equals to v is x. I'm going to have x multiplied by 12x multiplied by 1 plus 2x raised to the power 2 raised to the power 2 minus u. U is what? U is 1 plus 2x squared plus 3. And 1 plus 2x squared raised to the power 3. So I'm going to have minus 1 plus 2x squared raised to the power of 3 multiplied by derivative of v. Derivative of v is 1. So I'm going to have multiply 1. Okay? This all over v squared. Now v is x. So I'm going to have the square of x, which is what? X squared. Do you understand? See, let me tell you, anytime you encounter a question that is in quotient form, you understand? Just know that you are using chain rule. You understand? You are using quotient rule. Are you getting it? If you encounter a question that is in quotient form, that is the function contains bracket, it contains division. Just know that you are using quotient rule now. But there are some questions that even though you are using quotient rule, the numerator or the denominator, you have to use chain rule to differentiate it. Are you getting it? That is why I taught you chain rule in the previous class. So if you missed the class, make sure you watch the class, okay? So for this, I'm going to have derivative of f of x will be equals to x times 12x. That is what? 12x squared. 12x squared multiplied by 1 plus 2x squared raised to the power of 2 minus 1 plus 2x squared raised to the power of 3 all over x squared. So now what you have to do next is that you just have to expand the bracket and then simplify, okay? Now let's look at the third work example. We are asked to differentiate f of x equals to 1 plus x raised to the power 3 over 2 all over the square root of x. Okay, you can do this in two ways. Okay, you can use the quotient rule, and also you can just simplify and then differentiate it using polynomial rule. You understand? So I'm going to use that simplification method. F of x can be written as 1 plus x raised to the power of 3 over 2 multiplied by 1 over x raised to the power of 1 over 2, you know, because the square root of x is what? X raised to the power of half. You understand? So for this, I'm going to have f of x be equals to 1 plus x raised to the power of 3 over 2 multiplied by x raised to the power of negative 1 over 2. Do you understand? Okay, now open the bracket. You're going to have f of x equals to x raised to the power of negative 1 over 2 times 1. That is x raised to the power of negative 1 over 2. Okay, x raised to the power of negative 1 over 2 times 3 over 2. You're going to have, please pay attention, x raised to the power of 3 over 2 plus minus 1 over 2, right? So f of x is equals to x raised to the power of negative 1 over 2 plus, okay, now 3 over 2 minus 1 over 2, that is what? 1. So I'm going to have x raised to the power of 1. Well, you can do it. 3 over 2, the answer is 1. LCM is 2. 3 minus 1, that is what? 2 over 2. 2 over 2 is what? 1. Okay, so that's how I have 1 here. So f of x is equals to x raised to the power of negative 1 over 2 plus x. Now we can differentiate this. Derivative of f of x will be equals to negative 1 over 2 x raised to the power of, now negative 1 over 2 minus 1 plus x. Now if you differentiate x, you're going to have what? 1. So I'm going to have 1 here plus 1. Okay, f of x will be equals to negative 1 all over 2x. Now negative 1 over 2 minus 1, that is what? Minus 3 over 2. So I'm going to have minus 3 all over 2 plus 1. Okay, so derivative of f of x will be equals to negative 1 over 2 multiplied by 1 over x raised to the power 3 over 2 plus 1. Derivative of f of x will be equals to negative 1 all over 2 times x raised to the power 3 over 2, that is 2x raised to the power 3 over 2 plus 1. Do you understand? Okay, from this point I'm going to have derivative of f of x be equals to negative 1 all over 2 roots x raised to the power of 3, okay, plus 1, which is the final answer. Do you understand? So, and also, if you make use of the quotient rule to differentiate this, you're still going to have this as the answer. Okay,